Good morning, dear students. Am I audible? Good morning, dear students.
Good morning, sir. Audible.
Yeah, welcome to this design and analysis of algorithms lab. Okay, so today we are going to have two types of implementation. The first one, we are going to consider the Prince algorithm. Okay, the first one today, what we are going to have is the Prince algorithm, and then after this, we are going to have Kruskal's algorithm. So these two algorithms already I have explained in my theory class. Okay. So both of these algorithms they are used to find out what? They are used to find out.
Minimum cost spanning tree.
Minimum.
They are used to find out minimum spanning tree. So MST means minimum spanning tree. So this is what today's discussion. So first we are going to take Prince algorithm. Okay. Okay, dear students, I am audible now.
Yes, sir, audible.
Okay, fine. So first we'll take Prim's algorithm. So of course the objective of the Prim's algorithm is to find out the minimum spanning tree, and of course this is the modified version of Dijkstra's algorithm. So that is what the single source shortest path problem, that is I'm going to engage in my next class. Okay. So then the application of this Prim's algorithm, they are helpful in routing applications, networks, okay, computer networks, helpful in communication networks, okay. So then coming to this spanning trees, already we have solved few problems on this now. So I am going to give a problem here. First one, so take the graph here. All of you take this. So this is the graph. Whether we have solved this problem in theory. The problem solved ಮಾಡಿದ್ವಿ ನಾವು ಏರಿಯಲ್ಲಿ. Whether this problem has been already solved in theory. Yes or no? Yes, students. Have we solved this problem in theory? ನೋಡಿ ಸ್ವಲ್ಪ check once. Yes, students. Whether we have solved this problem in theory?
Yes, sir.
Okay, what is the cost we have obtained? Minimum cost. How much? ಎಷ್ಟು ಕಾಸ್ಟ್ ಬಂತು? ಸಾಲ್ವ್ ಮಾಡಿಲ್ವಾ? Check once in the book notes. In greedy techniques.
ಸರಿ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ.
ಮಾಡಿದ್ದೀನಲ್ವಾ? ಎಷ್ಟು ಬಂದಿದೆ ಕಾಸ್ಟ್ ನೋಡಿ. How much cost? Minimum cost you have obtained? If you have solved, do tell me the cost.
$150.
Okay. So the cost of this spanning tree minimum cost is 150. So now we have to convert this into a matrix called as which type of matrix we have to convert? We have to convert this graph.
Adjacency matrix. Adjacency matrix.
ಅಂದ್ರೆ ನೋಡಪ್ಪ 0 1 ಅಂತ ಇರುತ್ತೆ. ಈ ತರ ಇರುತ್ತೆ. ಅದು ಸಪೋಸ್ ಈಗ A ಇಂದ B ಗೆ ಇದೆ ಅಂತ ಒಂದು ಎಡ್ಜ್ 1 ಅಂತ ಬರುತ್ತೆ. ಸಪೋಸ್ ಇಫ್ ದೇರ್ ಇಸ್ ನೋ ಎಡ್ಜ್ ಫ್ರಮ್ A to C 0 ಬರುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಕಾಸ್ಟ್ ಇರುತ್ತಲ್ಲ, ಎಲ್ಲಾದ್ರೂ ಮೇಲ್ಗಡೆ ಕಾಸ್ಟ್ ಇದೆ. A to B 40 ಅಂತಂದ್ರೆ ಸೊ ಇಲ್ಲಿ ನಮಗೆ 40 ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ನಾಟ್ ಅಡ್ಜಸೆನ್ಸಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಇದನ್ನ ನಾವು ಕಾಸ್ಟ್ ಅಡ್ಜಸೆನ್ಸಿ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಅರ್ಥ ಆಯ್ತಾ? ಏನಂತ ಕರಿತೀವಿ? What we call the matrix?
Cost adjacency matrix.
Okay, fine. How many vertices are present here?
5. 6, sir.
6. So cost adjacency matrix of dimension must be, it is of dimension, how much?
6 cross 6.
6 cross 6. So now I'm going to draw the cost adjacency matrix. Can you see this? Okay, so a 6 cross 6 mesh, what I have drawn here. So label the rows and columns. So there are 6 rows, okay, and 6 columns. 1, 2, 3, 4, 5, 6. Because there are 6 number of vertices, I have to draw a cost adjacency matrix of dimension 6 cross 6. Okay. Now, what is the principal diagonal of this matrix? The principal diagonal of
0.
It is 0 because cost of visiting 1 to 1, cost of visiting 2 to 2, cost of visiting 3 to 3. And ಈಗ ಶಿವಮೊಗ್ಗದಿಂದ ಶಿವಮೊಗ್ಗಕ್ಕೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು? 0 ಅಲ್ವಾ? Right. So 1 to 1 is 0, 2 to 2 is 0, 3 to 3 is 0, 4 to 4 is 0, 5 to 5 is 0, 6 to 6 is 0. Now 1 to 2, see 1 to 2, what's the cost?
60.
60. Now 1 to 3, what is the cost?
10.
1 to 3, what is the cost?
10.
10. 1 to 4?
Infinity.
Okay. 1 to 5?
Infinity.
1 to 6?
Infinity.
Okay. 2 to 1?
60.
2 to 3?
Infinity.
2 to 4?
20.
2 to 5?
40.
2 to 6?
70.
Very good. 3 to 1?
10.
3 to 2?
Infinity.
3 to 4?
Infinity.
3 to 5?
Infinity.
3 to 6?
50.
50. Next, 4 to 1?
Infinity.
4 to 2?
20.
20. 4 to 3?
Infinity.
Okay. 4 to 5?
Infinity.
4 to 6?
80.
5 to 1?
Infinity.
5 to 2?
40.
Okay, 5 to 3,
Infinity.
5 to 4,
Infinity.
5 to 6,
30.
next 6 to 1, okay, 6 to 2, 70, 6 to 3, 50, 6 to 4, 80,
80.
6 to 5.
30.
So this is called as a cost adjacency matrix. Okay, work ಪண்ರಾ ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳಿ.
Yes, sir.
ಆಲ್ ಆಫ್ ಯು ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳಿ, ಬಿಕಾಸ್ ನಾನು ಪ್ರೋಗ್ರಾಮ್ ರನ್ ಮಾಡಬೇಕು, ಅವಾಗ ನೀವು ಅದನ್ನ ವ್ಯಾಲ್ಯೂ ಹೇಳಬೇಕಾಗ್ತದೆ ನನಗೆ. ಓವರ್.
Yes, sir.
Okay, now so once you convert this, okay, into minimum spanning tree, so the tree in a given forest will be like this. So this is what the output is, I hope. Yes, check ಮಾಡಿ. Because if you introduce any other else, it will create a loop. Yes, ಇದೇ ಔಟ್ಪುಟ್ ಬಂದಿದೆ ನಿಮಗೆ.
Yes, sir.
ಓಕೆ, ಸೊ ಪಾತ್ ಡಿಸ್ಟೆನ್ಸ್ ನ ಬರೀಬೇಕಾಗತ್ತೆ. ಪಾತ್ ಡಿಸ್ಟೆನ್ಸ್, ಪಾತ್ 1 to 1 to 3, what is the cost? 10. Next, okay, 1 to 1 ಇದೆ ತಗೊಳ್ಳೋಣ. 1 to 1 0, 5 to 2, 5 to 2 40, then 1 to 3 10, then 2 to 4 20, 6 to 5 30, three to 6 50. Okay, the total cost is ಎಷ್ಟು?
150.
150. ಇಷ್ಟು ಬರ್ಕೊಳ್ಳಿ. completed? Yes, yes, students.
Yes,
Yes,
sir.
sir.
Okay. So this is Prince algorithm. The next Kruskal's algorithm is over. Shalaram, Bharat, Hadasla. I will copy it all of you.
Okay, sir.
So next is Kruskal's algorithm. Okay, Kruskal's algorithm. So once again, the algorithm is used to find out the minimum spanning tree, provided that we have a until the directed acyclic graph. Okay. So for a given graph, G is equals to V comma E, set of all vertices and number of edges. And it is also similar to Tim's algorithm. The logic of this is the selected edges results in a cycle. It will be neglected, and the procedure will be considering all the n minus 1 edges will be selected, which results in a minimum spanning tree. Now I am going to give a graph for all of you to tell me whether this graph has been already solved in theory. Tell me whether this has been already solved in theory. Yes, students. That this graph is already solved in theory classes. Yes or no?
Already solve ಮಾಡಿದೀವಿ sir.
Okay, what is the cost? Minimum cost, your time.
74.
Okay, so let us check. So, graph ಬರ್ಕೊಂಡ್ರ ಎಲ್ಲರೂ? Have you taken the graph?
Yes, sir.
Okay, now the thing is we have to convert this graph into what matrix? Cost adjacency matrix. What is the dimension? What is the dimension of this matrix?
Nine cross nine.
ಗ್ರಾಫ್ ಸ್ವಲ್ಪ ತಪ್ಪಾಗಿದೆ. This is 9. This is not 3. This is 9. This is 9. Okay? ಇಲ್ಲಿ ನೋಡಿ, ಇದನ್ನ 9 ಮಾಡ್ಕೊಳ್ಳಿ. ಇದು 3 ಬರ್ತಿದೆ, 9 ಮಾಡ್ಕೊಳ್ಳಿ. ಸರಿನಾ? So what is the dimension of the matrix? The dimension of the matrix is
0.
ಇಲ್ಲಪ್ಪ 9 cross 9. ಅಲ್ವಾ? So 9 cross 9 would be the dimension. So now I am going to draw the cost efficiency matrix. Okay.
Cost of 7 to 9.
ಎಷ್ಟಪ್ಪ? ಅದೊಂದು ಬರ್ತಿಲ್ಲ, ಸಾರಿ. Cost of 7 to 9 is 12. 12. Four, 5, 6, 7, 8. So 9 columns we have 3 plus 2, and similarly 9 rows we have to 3, 4, 5, 6, 7, 8, and 9. Okay, so this is a mesh of 9 cross 9. So one label the columns 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 9. As usually, the principal diagonal will be always what?
0.
0. So fill the principal diagonal with 0 values. Okay. Now you fill the rest of the things 1 to 2.
8.
1 to 3.
Infinity.
Next we have 16, infinity. 8, 0, 16. Infinity. 2. Infinity. 16. 0. 14. 58. Double infinity 4. And 28 triple infinity. Then fifth triple infinity 18. 20, 6, mother infinity, 8, 28, 20, 0, 4, infinity, 5 times infinity, 4, 0, 2, 2, 22, 3, 2, 0, 2, infinity, 4, 12, 40. So this is the matrix. According cost adjacency. Copy this cost adjacency matrix and inform me. Over.
Yes, sir. Copy.
Okay, fine. Now the output what we have obtained is like this. So this is the tree, minimum spanning tree. 8, 16, 2, 4, 8, 4, 14, 18, and of course the cost is 74. The output be like this. 7 to 8 is first hit. 7 to 8. It is the cost is 2. Second hit is 3 to 9, 4. Then we have third one 6 to 7. 6 to 7, it is 4 again. The fourth one 1 to 2. 1 to 2 is 8. Then we have fifth one, that is 3 to 6, 8. 3, 6, 8. Sixth one 3 to 4. 3 to 4 is 14. Then 7, 1 to 8. 1 to 8, 16. Then we have 8. That is 4 to 5. And the value is 18. 4 to 5. So 4 to 5 is 18. The total cost is how much?
74.
74. To copy this so that we can execute the program. Once it is over, you tell me. Or
Yes, sir.
okay, then shall we execute the programs and check?
Okay, sir.
ಆಯ್ತಾ ಎಲ್ಲಾರ್ದು ಬರ್ಕೊಂಡು shall we start execution?
Yes, sir.
Fine. So now I am going to up C double plus. Dear students, can you see the C double plus CPP editor?
Yes, sir. It is visible.
Okay, so this is the print algorithm now. I am going to execute this. So control F9. So enter the number of nodes. Please tell me the Prim's algorithm just we have solved. So how many vertices we have? How many
6.
nodes?
6.
Esto?
6.
Okay. So tell me the cost matrix.
150.
0.
0.
Matrix L. 0.
60.
60.
10.
And
Infinity.
how you give infinity? How can you give infinity in computer?
No, sir.
So that is why we can give a large value like this. Okay. A large value. That it is a large value, it seems to be an infinity. So first row is over. Next, 60, 0, infinity, 20, 40,
70.
70.
70. Next row, Elapa.
10.
Okay.
0. Infinity.
Okay.
Infinity.
Okay.
50.
Very good. Next.
Infinity.
Fine.
20.
Okay.
Infinity.
Fine.
0.
Okay.
Infinity.
Okay.
80.
Okay. Next row.
Infinity.
Fine.
40.
Okay.
Infinity.
Okay.
Infinity.
Okay.
0.
Okay.
30.
Fine.
Infinity.
Okay.
Infinity.
I think 70 answer only.
70.
70.
70. Okay.
50.
Okay.
80.
Okay.
30.
Okay.
0.
Fine. So this is the cost adjacency matrix or cost matrix of dimension 6 cross 6. Now I'm going to give this as an input for my Prim's algorithm. Let us find out what is the shortest path or shortest spanning tree with the minimum cost. Check the output, dear students.
Yes, sir. Correct ಇದೆ.
Sir, idenappa?
Ha, sir.
So this completes Prim's algorithm. Okay, if you are confident, we shall go for Kruskal. Shall we?
Yes, sir.
Now you take Kruskal's algorithm. So this is Kruskal's algorithm. It is also used to find out the minimum spanning tree. Okay. So I'm going to compile this. Now I'm going to execute this. So it give the same example what we have taken. What is the dimension? What's the
9.
dimension? 9. So 9 cross 9. So 9 vertices. Okay, is the 81 values you have to give. So ಇದನ್ನ ಕೇಳಿ ನಾನು ಎಂಟ್ರಿ ಮಾಡ್ತೀನಿ. Yep. 0.
8.
Fine.
Infinity.
Okay.
Infinity.
Hmm.
Infinity.
Hmm.
Infinity. Infinity.
Hmm.
16.
Hmm.
Infinity.
So first row is over. Next, second row.
8.
Okay.
0.
Okay.
6, sir.
16 o'clock.
Ha, sir. Only 6.
2 to 3 ಅದೇನಪ್ಪ. 2 to 3 16 ಕಣಪ್ಪ ಅದು. ಗ್ರಾಫ್ ಅಲ್ಲಿ ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀರಾ ನೋಡಿ 2 to 3 ಗ್ರಾಫ್ ಅಲ್ಲಿ
16, sir.
16 ಅದು ಓಕೆ ಸೊ 2 to 3 16 ನೆಕ್ಸ್ಟ್ ಹೇಳಿ
infinity,
ಓಕೆ 2 infinity 3 infinity 4 infinity next 22
infinity,
infinity second row is over third row
infinity,
hmm.
16,
okay
0,
okay
14,
okay
infinity,
okay
8,
okay
infinity, 4,
okay so third row is over fourth row double infinity 14 0 18
28, infinity, infinity,
okay fourth row is over fifth row
infinity, 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 18,
okay
0,
okay
20, infinity, infinity, infinity,
3 times infinity next sixth row
infinity, 8,
okay, double infinity ಸರಿ ಇದೆಯಾ ಕರೆಕ್ಟ್ ಇದೆಯಾ
Yes, Yes, sir. sir.
next seventh row 3 times infinity 4 times infinity 5 times infinity next 4 0 to 12 so eighth row 16 22 3 times infinity 4 times infinity 2 0 14 correct
Yes, sir.
next last row ninth row correct ಏನಪ್ಪ ಸರಿ ಇದೆಯಾ ನೋಡಿ cost efficiency matrix
yes,
Sir,
sir,
ಇದೆ, sir.
so shall we give this as an input for our computer algorithm Kruskal's algorithm
Yes, sir.
okay check the cost
Correct ಇದೆ, sir.
ಓಕೆ ಅಪ್ಪ ಸೊ ಎರಡು ಪ್ರೋಗ್ರಾಮ್ಸ್ ಮಾಡಿದ್ದೀನಿ ಈ ಎರಡು ಪ್ರೋಗ್ರಾಮ್ಸ್ ನ ಶೇರ್ ಮಾಡ್ತೀನಿ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಸೊ ಯು ಎಕ್ಸಿಕ್ಯೂಟ್ ಅಟ್ ಹೋಮ್ ಓಕೆ
sure, sir,
ಸೊ ಡೆಫಿನೆಟ್ಲಿ ದೆನ್ ಅಸೈನ್ಮೆಂಟ್ ನಾನು ಅಪ್ ಮಾಡಿದ್ದೀನಿ ಸೊ ನೀವು ಅಲ್ಲಿ ಸಬ್ಮಿಟ್ ಮಾಡ್ಬೋದು ಅದು ಅಪ್ ಆಗಿರಲಿಲ್ಲ ಐ ಹ್ಯಾವ್ ಮೇಡ್ ಇಟ್ ನೌ ಇಫ್ ಎನಿಬಡಿ ಸ್ಟಾರ್ಟ್ ಸಬ್ಮಿಟಿಂಗ್ ದ ಅಸೈನ್ಮೆಂಟ್ ಇಫ್ ಯು ಆರ್ ಕಂಪ್ಲೀಟೆಡ್ ಓಕೆ ಸೊ ವಿತ್ ಆಲ್ ದಿಸ್ ಶಾಲ್ ವಿ ಸ್ಟಾಪ್ ಹಿಯರ್ ಟುಡೇ
okay, sir,
okay dear students so I will continue tomorrow theory class so till then you execute these programs at your home okay thank you so much for joining Ada Lab I request all of you to give the attendance to the chat box if anybody have not given can give it now